This is the worksheet that you should have printed out, and hopefully you did. I'm going to go ahead and show you some of the solutions to these problems. You also have access to Paul's online notes. That's where I got this worksheet, Paul's online notes. There's a link on the Canvas site, and all of the solutions, not videos, but just all the solutions printed out, are on his website. It's a great website, great resource for Calc BC. So anyway, I'm just going to go ahead and do a couple of these problems. Starting with number 2, you can see we have to use the chain rule to find the derivative of g of t. And using the chain rule, it's important to identify the outside function and the inside function. And hopefully you can see that the outside function is the power function, so we have something being raised to a power. And so when we have something being raised to a power, we have to take the, let's see, we have g prime of t. Let me do this first. G prime of t is equal to, we take the power and we bring it out in front. We multiply it by the inside, so whatever, so the power multiplied by the something, and the something is 4t squared minus 3t minus 2, sorry, plus 2. And then we have to subtract 1 from the power. So negative 2 minus 1 is negative 3. And then we have to multiply by the derivative of the inside. And the derivative of 4t squared is 8t. The derivative of minus 3t is minus 3, or negative 3t, negative 3. And that's it. I could simplify it by moving the negative exponent to the bottom, put it, make it positive, but I'm just going to go ahead and put a box around this because that's what g prime of t is equal to. Number 4, we can see we have to take the derivative of a trig function, and the trig function here is the cosecant of something. So again, the outside function is the cosecant, and so we take the derivative of the outside first, and the derivative of the cosecant is c the negative. I always remember that if we're taking the derivative of a trig function that starts with the letter c, then we know we're going to have a negative derivative. So the derivative of the cosecant is negative cosecant of whatever it is, and that whatever is 7w, cotangent of, again, 7w. So that's the derivative of the outside, but then we have to also remember to multiply by the derivative of the inside, and the derivative of 7w with respect to w is 7. And that's it. Okay. For number 5, we have a constant on the outside. So that constant's just going to go ahead and follow along all the way down to the very end of the problem. So we're just going to keep that constant out in front. Okay, so g prime of w, oops, let me back up a second here. G prime of x is equal to, again, that constant's just going to come along for the ride, 2 times, and then the outside function is sine, and we know the derivative of the sine is the cosine, so 2 times the cosine of the inside, whatever the inside is, and that's 3x, plus the tangent of x. Okay, and so then that's the derivative of the outside. Now we have to multiply that, cosine of that stuff, times the derivative of the stuff. And the derivative of 3x, so we're going to do that first. Remember, the derivative of the sum of 2 functions is the sum of the derivatives. And so we can just take the derivative of each of these terms separately. And so we get the derivative, let me make sure I get purple here. Derivative of 3x is 3 plus, and then the derivative of the tangent of x is the secant squared of x. And that's it. Put a nice box around that. And let's scoot on down to number 8. So we see we have the g of x is equal to e to something. Okay, so again, that something is going to be our second or inside function. The e to something is our outside function, and we know that the derivative of the e to something is the same thing. So all we have to do is just rewrite the original function here. So the derivative of g of x is e to that something, And then we also make sure we have to multiply by the derivative of the something. Well, the derivative of 1, so the first thing we're going to look at here is the derivative of 1. Well, the derivative of 1 is 0, and then the derivative of negative cosine x. Okay, remember the derivative of cosine is negative sine, and so the derivative of negative cosine would be negative negative sine, or just the sine of x. Okay. And if I did too much in my head there, then write it out and make sure that you know how to get that answer. I wish I didn't circle that negative cosine x because it looks kind of bad, so I'm going to do that again. My apologies. I wanted to delete that part. But anyway, we have the derivative of negative cosine, which is the sine of x. That looks much nicer. Okay. And finally, number 10, u of t. So we're taking the derivative of u of t with respect to t. And here we have the derivative of an inverse tangent function of the inverse tangent function. So the outside function is the inverse tangent. The inside function is the 3t minus 1. Well, we just have to remember the rule, okay? Because it's an inverse tangent, I'm going to go ahead and remind myself of what the rule is. So the derivative of the inverse tangent of x is equal to 1 over 1 plus x squared. It's probably the easiest inverse tangent or inverse trig function to remember the derivative rule for. But so anyway, the u prime then would be equal to whatever we're taking the inverse tangent of goes right there. Okay, so we have 1 plus, and what is that of thing? So that of thing is 3t minus 1. Okay, and we have to square that. Now, if that were just a t, we would be done. So we don't have just a t, we have a 3t minus 1. Since that's not just t, then we have to multiply by the derivative of that thing, and the derivative of 3t minus 1 is just 3. That's it. As you can see, I'm not simplifying and making these look really pretty. I'm just going ahead and just finding the derivative of each of these functions, and then I will leave the simplifying to you guys. And you can take a look at the solutions on Paul's online notes so you can see, maybe if you can't figure out how to simplify it completely, look at the solutions on his online notes. Most of the time when we're finding derivatives, we're going to also be plugging in values for the variable, so we can actually find the slope of the tangent line at a particular value. But here we're just finding derivatives. So chapter 3, we're just, or in this lesson, we're just focusing on finding the right derivatives. It's a pretty rote learning, but no application type problems yet. But I just want to make sure that you're solid with finding derivatives, and I'll see you in the next video.